Okay, for the special bearing, yes, we're going to create another section view, a full section view. And this time we're only going to put 2 views on. Having the third view with a cylindrical object most times isn't necessarily needed. I'm getting all the linear dimensions in this view because essentially in this case the top view would be exactly the same, being that it's cylindrical. But we do want to mark these centers. This is a special tool in Fusion 360. Instead of putting in individual center marks, we can run a center mark pattern for these 3 holes and the diameter they're on all at one time. So we'll take a look at that one, and essentially what would be known as a hole callout. We can use our thread hole option. We will have to go back and modify this. I don't know why it happens that way. But we can get all this information, or a majority of this information, to happen with the leader line. Just like dimensioning a diameter, we'll get most of this dimension information at one time. The formatting's a little bit off, but we're going to do a text override to combat that. So we'll go through, we'll create the section view again, edit this text that's automatically generated from the section view, but mainly looking at adding these center marks or center references, as well as this thread hole callout. Okay, so I have it open, and we're going to create a drawing from this design. Scale of 2 to 3. It's going to work out good here since we're only putting in 2 views. And I am just going to project the isometric for visual reference. Because when we create the section view, this right side view or the section view will automatically be created. Solid and scale down our isometric. We may have to move these around as we continue this. So I want to create a section view. Again, find some point of reference so it's right down the middle. AA is going to happen because it's the first time using it. Hatch marks automatically come in. We do have some center marks. This initial diameter, we do need this center mark, and we need some center lines. We do have this line that goes down the middle, and also for the counter sunk hole. Extend past the edge of the object. And this whole thing is cylindrical. All right, to get center marks for these 3 counter sunk holes and the diameter they are on, we can use this center mark pattern. Once I select on one of these, should do them for all. Top one's referencing. And reference another one. That should be all I need. Go ahead, all 3. Center line is automatically generated. Center marks are automatically generated. And they are, for better or worse terms, pointing to the center. They're perpendicular to the center mark. So this is a very convenient feature in terms of dimensioning or adding your center marks and center lines to this circular pattern. So that is using the center mark pattern, reference them, automatically generated, line type automatically generates, very convenient tool. So on any 3 of these holes, we can dimension this thread hole insert. By selecting on one of these, it will generate quite a bit of information. 3 times the diameter and the depth, the countersink diameter and the countersink angle. This is all dimensions that we do need. When I created the drilled hole using the hole tool, I put in just 2 inches so it went all the way through. Yeah, okay, I made it 2 inches deep, but when that's drilled all the way through, you're not going to stop at exactly 2 inches in terms of manufacturing. We actually have to get rid of this or put through all here. This was just generated based on the fact that that is the dimension that you input for depth just to send it all the way through. If it was to a given depth, we're not going to change this. So this is a through all. Next is the precision. We typically do not see decimals in a fraction. Why this does not follow along in terms of dimensioning, I don't know, but we're going to set the precision here. And also the overall precision. We only need to have 3 decimal places for this part, and we're at 4. So, I don't know, first things first, let's change our precision. Angular dimensions are already set to 0, but it's showing up with 4 decimal places here. So this has to be something that we override. We're just going to take this text box out, and we're going to put in 70 degrees manually. I haven't found a better way to do that. The depth. The depth is actually through all for this one. Or if nothing is given, actually that'd probably be easier. Those drill holes, they're the smaller diameter. Let's not even put through all in. If depth is not given, it is assumed, and we don't want to assume, but that the holes are going all the way through. This one happens to be left justified. That's not centered. Let's stay with the left justification. If I had this on the other side, I would want right justification. How can I show you that? If I dimension this hole, I would want right justification. Sorry, this is left. The other one was right. So I'll do it again here. This is okay. Too many decimal places. You can't change the precision just for this one for some reason, and it's not matching the precision we've already set. Again, depth, we don't want to assume, but it's going all the way through. Our countersink symbol came in. All 3 holes are the same size. We're ready to continue dimensioning. Again, if I have to move this, I can move this. Oh, I should have done that better. It needs to be pointing to the center. Now it's pointing to the center. I'm going to have a couple dimensions here that are going to interfere with that. All right, continue on. This inner diameter is a tolerance. We have done a tolerance before. The tolerance is 1.438 to 1.436. And this is just going to be a text override to 1.436. 3 decimal places. There's my tolerance for that reamed hole. Countersink information is given. Outside diameter, inside diameter, okay. Some linear dimensions. This outer diameter. And we have this inner diameter. And then we have this little notch cut out. gaps on our extension lines. And we should have a dimension of 0.2, and this should fit in between the arrowheads. If I have to flip this text to the opposing side, I can. So I'm just double checking. Well, 0.62. I'm missing a dimension of 0.62. Find a convenient spot to put that. Give myself a little room here. I do need a dimension of 0.62 for the thickness of this material. 312. We need the diameter that this is on. Good thing I double checked. That these three holes are on a diameter of 312. Looks good. I'll move this isometric view so it's not interfering. Section text, 0.1, and we may need to move this close to the section view. You want to know what it's referencing. All right, creating a section view again. Thread hole. Nope. Edit the dimension text, depth in particular, number of decimal places for the angle. Center pattern, center mark pattern, any tolerance. Should really take care of this one.